EMF and current is induced in the secondary EMI chapter. So actual power of the circuit, it is the actual measured power, the quality factor of a series resonant circuit increases divided by Vp equals Ns divided by Np. The sharpness curve. Yesterday we studied resonance curve. How sharp the curve is. If I need to vary or change AC voltage, hello students, this is my last session of discussion on the topic alternating current, where we shall discuss on the topics quality factor and transformers. So before I begin today's session, we just recall the phenomenon of electrical resonance, where we told resonance means frequency matching condition, and whenever resonance happens in an LC or AC circuit, XL becomes equal to XC at a particular frequency of the applied voltage, what we call as resonant frequency. We saw in the previous class, inductive reactance becomes equal to capacitive reactance. XL becomes equal to XC, and we told at this condition impedance is minimum, opposition to the flow of AC current is minimum, and maximum current flows through the circuit. Now, the topic that we discuss in today's class is called quality factor, something that is linked with the quality of the sharpness curve. Yesterday we studied resonance curve, how sharp the curve is, how blunt the curve is. It depends upon quality factor. Now, quality factor, the so-called Q factor of a series resonant circuit. I am defining quality factor for a series resonant circuit is the ratio of the voltage developed across the inductor or capacitor at resonance to the applied voltage. Certainly absurd to understand. Q factor of a series resonance circuit, quality factor of a series resonant circuit is a ratio. What is the ratio? Ratio of the voltage across the inductor or capacitor to the applied voltage. So Q factor is VL, that is voltage across the inductor or voltage across the capacitor to the applied voltage. Whatever voltage you apply is called Q factor. But this definition precisely gives us what is quality factor. So we say it is the ratio of resonant frequency to the bandwidth of the circuit. Yesterday you saw the resonance curve. Half power frequencies F1 and F2. The difference of F1 and F2 is what we called the bandwidth. So the ratio of the resonant frequency to the bandwidth is what is called quality factor, or Q equals F0 divided by F2 minus F1. Resonant frequency is F0. F2 minus F1 is the bandwidth. My dear students, there was a 1-mark question asked. How does the sharpness of a resonance curve increase? Or how does the quality factor of a series resonant circuit increases? Most of my students had written increase the resonant frequency, Q factor increases. No, F0 is a specific frequency. If it changes, then it is no more called resonant frequency. It has a fixed value. For that frequency, resonance is achieved. So what do I do to increase the quality factor? I have to decrease the bandwidth. If this width is less, the curve becomes more sharp. Q inversely related to bandwidth. Kindly see here. As the bandwidth increases, sharpness decreases, Q factor decreases. So, thus if the Q factor is large, bandwidth is small and sharper is the resonance curve. So, if at all you are asked a question, how to increase the quality factor of a resonant LCR circuit, we have to decrease the bandwidth. If the bandwidth decreases, sharpness increases, which will increase the quality factor. Now, this is again an important note. Power in series LCR AC circuit. So power in series LCR circuit. My dear students, generally in DC circuits, power is defined as product of voltage and current. Alva, electric current chapter, master current or master chapter discuss ಮಾಡಿದಾಗ we saw P equals V into I. For a series LCR circuit, power is VRMS into IRMS into cos phi. So please to remember, power of a series LCR circuit P equals VRMS into IRMS into cos phi, where P is called true power or actual power of the circuit. It is the actual measured power. Product of VRMS and IRMS is called apparent power. It is called virtual power. That is not the true power dissipated in the circuit. And this is very important. Cos phi is called power factor of the AC circuit. ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಮಕ್ಕಳ, ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ಇದನ್ನ ಬಹಳಷ್ಟು ಸರಿ ಕೇಳ್ತಾರೆ. ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಆಫ್ ದಿ AC circuit represented as cos phi, where cos phi mathematically is calculated as R divided by Z. Ratio of resistance to the impedance is called cos phi. Cos phi equals R divided by Z. Parikshanali AC circuitina power factor calculate ಮಾಡಿ ಅಂದ್ರೆ it is R divided by Z. So how do we calculate power of an AC circuit? It is VRMS into IRMS into cos phi, where P is the true power, actual power dissipated in the circuit. VRMS into IRMS is the apparent power, virtual power, and cos phi is the power factor. Now, in an AC circuit with resistor, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, AC circuit where you had a pure resistor, was there phase difference between voltage and current? Yes. How much was it? Was there? No. In an AC circuit with a pure resistor, there was no phase difference between voltage and current. Phi is 0. Substitute here. Cos phi is 1. So power dissipated in a resistive circuit is VRMS into IRMS. What about purely inductive and capacitive circuits? There was no phase difference between voltage and current. Howda? Good. There was phase difference of 90 degrees between voltage and current. Either it was a pure inductive circuit or pure capacitive circuit. A phase difference of 90 degrees will appear between voltage and current. Cos 90 is 0. So power dissipated in such circuits is 0. So as you can see here, power dissipation happens only in a purely resistive AC circuits where the phase difference is 0. So we have P equals VRMS dot IRMS. This is a small assignment for you all. Please to try to get something called as Wattless current. I want you all to get the definition of Wattless current. Watt, something that is associated with power. Wattless andreno, powerless anta artha, which means current flowing through the circuit consumes no power. Then that is what we call wattless or idle current. If the current flowing through a circuit doesn't absorb power, dissipate power, ಒಂದು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿರುವ ಕರೆಂಟ್ ಪವರ್ ಅನ್ನು ಅಬ್ಸಾರ್ಬ್ ಮಾಡಲಿಲ್ಲ ಅಂದ್ರೆ ಅದನ್ನೇ ವ್ಯಾಟ್ಲೆಸ್ ಅಥವಾ ಐಡಲ್ ಕರೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಯಾವ ರೀತಿ ಎ ಸಿ ಸರ್ಕ್ಯೂಟ್ಸ್ ಅಲ್ಲಿ ಪಾಸಿಬಲ್? ಯು ಸೋ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ in inductive or capacitive circuits. My dear students, the last topic of discussion here, transformer, commonly used term. ಮನೆ ಹತ್ರ ಎಲ್ಲ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಗಳು ಅಂತ ಹೇಳ್ತೀವಿ. ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ಸ್. What is a transformer? A transformer is a device used to vary AC voltage and hence AC currents. Why do I use a transformer? If I need to vary or change AC voltage or AC current, I use a transformer. Now, see, usually for domestic purposes, we get alternating current basically at 220 volts and 50 hertz supply. Sometimes from the feeder lines, we may get current whose magnitude is more than 220 volts. There I have to reduce, step down the strength of the current. I use a transformer. Sometimes instead of 220, I may get 110, 100, where I have to increase the strength, step up again. I use a transformer. So a transformer is a device used to vary AC voltage or AC current. And it works on the principle of mutual induction. ಒಂದು ಪ್ರೈಮರಿ ಕಾಯಿಲ್ ಇರುತ್ತೆ, ಒಂದು ಸೆಕೆಂಡರಿ ಕಾಯಿಲ್ ಇರುತ್ತೆ. Change the current in the primary, EMF and current is induced in the secondary, EMI chapter. So very important 1 mark question again. A transformer works on the principle of mutual induction. So please to understand, a transformer is a device which is used to vary or change AC voltage and AC current What is the principle on which it works? Mutual induction. See, this is how we represent a transformer. One mark question mat puna keltare. Primary coil, secondary coil, and the core ant karitivi. So as in your mutual induction, this is the primary coil, secondary coil, and this is the core. Construction and working, refer to the material. I would like to give it as an assignment because this is nothing but again the explanation of mutual induction. Go back to EMI session last in that where I have clearly explained the mutual induction phenomena. This is again the working of a transformer. This is important. Turns ratio. Turns ratio of a transformer T is defined as Vs divided by Vp, which is equal to Ns divided by Np. Nenpitಕೊಳ್ಳಿ, turns ratio ಅಂತ ಕರಿತೀವಿ. Vs divided by Vp equals Ns divided by Np. What is Np? Number of turns in the primary coil. Ns, number of turns in the secondary coil. Np, turns in the primary coil. Ns, turns in the secondary coil. Vp, voltage across the primary coil. Vs, voltage in the secondary coil. So turns ratio is Vs divided by Vp, which is equal to Ns divided by Np. Now, if the turns ratio is less than 1, if T is less than 1, when will T be less than 1? If Ns is greater than Np or Vs is greater than Vp, number of turns in the secondary coil greater than number of turns in the primary coil, it is called step-up transformer. Step up. Number of turns in the secondary coil should be greater than number of turns in the primary coil. Ns less than Np. Number of turns in the secondary is less than number of turns in the primary. It is called step down transformer, and these are the two types of transformers. Now, so students, we have discussed the entire chapter. Very importantly, the nature of AC circuits, how voltage and current behave in AC circuits, the phenomenon of resonance, resonant frequencies, transformers. Kindly go through the sessions. Very important chapter. Many a times, almost all papers, numericals asked. In my next session, I come up with electromagnetic waves. Until then, thank you.